Hello guys, how you doing? It's your boy Dave. Um, how's everyone doing? We're trying to talk about NASA and what they discovered. Just a little dive into the universe, all right? And I don't think I've ever done a live stream where we discussed about the universe. I know many people like such discussions, but the all the videos I've done on that has always been pre-recorded. Okay, so just join, like this video. Just click that thumbs up icon below so that the likes will spike up. Okay, and then share so that people will see. All right. Um, I'm waiting for people to join. At the same time, all right. So if you've joined, just drop a comment. I'm waiting to be able to see myself. Just drop a comment in the comment section below that you can see me. All right. So NASA said that they have found water on the moon. What does that mean? So far, there is no other planet in the whole universe. Remember that there are trillions and trillions and trillions of planets. Trillions, uncountable. In fact, let me even put it like every star, all right, has a lot of planets around it. The planets don't give off light. The stars are like rocks that are burning. So because they are burning, we can see them because they are giving off light. But the planets are not burning. In fact, their burn is they are in fact they have been burning, but they are now much cooler. And the part of the planets that are burning are usually inside, like in the Earth now. The Earth core, the center of the Earth. The Earth is like an egg. The center of the egg is Earth is still burning, and is estimated to burn for another 4 to 5 billion years from now before it finally cools. But generally, the Earth is cooling down, all right, because of entropy, all right, it's cooling down. So if you're looking at the star, which is, let's say our sun is a star. If you're looking at the star from a very far distance, all right, you will not see the Earth. This planet we're in, you will not see us. Okay. So wait, if you're seeing me, please drop a comment. I need to be sure that I'm live because I can't see myself. I can't see myself. Just drop a comment. Let me know that we're together in this, all right? Okay, so let me just keep going on while I'm waiting for the first comments to trickle in. All right, so generally, um, you can see planets looking from a distance. What you can see are stars. The only time you can see planets is when they pass in front of stars. It's like you're seeing a bulb. Let's say a room is dark and you light a candle, all right? That candle did not illuminate the whole room, it just illuminated the environment. So if there is a butterfly or a fly, let's say a fly flying around that candle, you will not see that fly until the fly comes between you and that candle. Once the fly comes from the shadow, you can see, oh, something is passing. So that's how they see planets in front of stars. And when you see planets like that, there are a lot of issues that come with it. One of the issues could be that you you simply can't tell the nature of the planet. All right. Yeah, you can see a planet. You can see a planet, an opaque object, all right, traveling in front of the sun, but you can't tell the nature. You can't tell whether it has water or not. You can't tell whether it has clouds. You can't tell the color of the soil. You can't tell the surface, what the surface is made of, Different stars are made up of different things. I mean, different planets, all right? So different planets are made up of different things, different colors, different the surfaces are different. Some are made up of diamond. There is one or two planets they have discovered that the surface is diamond. This diamond we're dying for here. That the surface of the star, the not the star now, but the the planet is diamond. Some are glass. You understand? But what they have not seen so far is water. Even though the planets in the distance can contain water, it's difficult to tell. You can't easily tell because what you're seeing is just the shadows, all right? The shadow or whatever impression they make from the star that they are orbiting, all right? And if so many stars are orbiting, so many planets are orbiting a star, you wouldn't know until each one passes the star. And the thing is that you can't tell, you can't easily tell how many planets are orbiting the stars. You don't know whether when the one that was orbiting it has come round again. Some stars are so big that it can take so many years. For instance, it takes I think 508 years for Jupiter to orbit the sun once. Okay, let me check. How long does it take Jupiter to orbit the sun? Let's see how many years. 12 years, yeah. Jupiter is 500 times bigger than the Earth, but it takes it 12 years to orbit the sun. 12 years. So for 12 years, uh, so let's say on the day a child is born on Earth, Jupiter started orbiting the sun, trying to go around the sun, right? And after, let's say, by the time the Jupiter would have completed one orbit around the sun, the child is 12 years old. If it completes two, the child is 24 years old. Now complete it, think about it, like that. So because of what the distance, how far away? Let's see another planet like Pluto. Pluto. How long does it take Pluto to orbit the sun? 248 years. So the last time Pluto orbited the sun was when when they first invented guns, when they were still fighting American Civil War. American Civil War was, I think their independence was 244 years ago. That was the last time Pluto, a planet called Pluto. Why? Because it was so far away. It is, not for wars. It is so far away. So far away. So when you look at it in that respect, you see that it's difficult to tell if there's water. Now, why is water important? Water is important in planet because it's a sign of life. Once there is this kind of water we have, then it means that life would generally evolve on that planet. Because one of the primary reasons life evolved here on planet Earth is because of water. There is no other planet in the solar system that has water, at least that we have confirmed yet. All right. Now, if the other planets like Pluto, Venus, Saturn, not Venus now, Venus is it's boiling hot, it's too close to the sun. All right. But when you talk about the ones that are in the distance, like Saturn, Uranus, Pluto, those ones, they are, we can't exactly tell what the surfaces are or what the surface feels like, whether it's gaseous, whether it's a paste, you know. But one thing is, it can't have liquid water because that place is too cold. We know that water freezes at a certain temperature, you know. So Earth is in somewhere they call the Goldilocks zone, not too far from the sun, not too close, somewhere perfect. So water is able to evolve or come out, like ice is able to melt and become water in some parts of the earth, and some other parts it stays ice. That's the perfect position for any planet to be in. So when we're looking for planets that can have alien life or have any kind of life in it, we're also looking for water. Now, water is not the only thing we're looking for, but we know that other things are there. For instance, carbon. All right. After studying the periodic table, scientists figured out that, oh, geez, there's an element that's abundant in nature, and that is carbon. And that's the primary thing that all living things have. All living things have carbon. So if we find another living thing somewhere in the universe, most likely it has carbon. Most likely, most definitely. All right. So if that living thing exists, it has carbon. If it has carbon, there's a chance that it may start looking like things on Earth. For instance, it might be bipedal or quadpedal, like for it to move from place to place on top of the planet where we find it. For it to move from place to place, it has to have a way to move. So it has to have at least two legs. Two legs is bipedal like human beings and chickens. Chickens have two legs. Some dinosaurs have two legs. What else has two legs? I think kangaroo. Kangaroo has two legs. Like walks with two legs. All right. Which other thing has two legs? I wouldn't know. So for if we find an alien life somewhere in the universe, it has to have two legs to start with, you know what I'm saying? Then it also has to have it also has to have um or four legs or more. For instance, spiders have more. I think spiders move with like eight legs. They move all over the place, you know. Or it can be an amoeba, you know, amoeba. Like amoeba doesn't have legs. Shifting so that they can move from one location to another. That's living things, all right? Here's what I mean. For you to move from where you are now to another location, you have to change shape. All right, the way you look now, you might be in a sitting position. You have to change shape until you come into a standing position. Then you start changing shapes to move from one location to another. That is walking or running or whatever. All right. Birds. Imagine for a bird to fly, it has to change shape and spread its wings. You know, so for a living thing to be able to move, it has to have that ability to morph shapes. So if we're seeing a living thing in any planet, we can predict what it will look like. It has to look like something that can morph, you know, change shapes. And now looking at different environments breeds different kind of living things that have different kind of shape changing abilities. You know what I'm saying? For example, um, on land, living things have either two legs, four legs, eight legs, you know, and the shape changing ability is just we already know what it is. But then on in the sea, we see that all fishes start looking alike. They have to be aerodynamic, you know. They have to have a pointed mouth, you know. They have to have a fin, you know, and a tail. That's fishes for you. Even animals that went into water that are not fish. For instance, sea lions. They used to be land animals. They crawled into water for survival to hunt fish. They are still aerodynamics, and their arms and legs are no longer arms. They have changed to fins. You get. So if a planet is all watery, we can predict what the life on it will be like. It's gonna be aerodynamic. All right. It's gonna look like something we see in the oceans. If it's all gaseous and things are there, that those things will have need to have wings, so they need to look like birds. All right. So if it is all just land, we can predict what it will look like. All right. So that then some other things that cannot be predicted easily is, for instance, what if all the water in that planet is underground oceans? You know, maybe you see a pond, but then when you enter the pond, you see that there is a large body of ocean underground. A good example is some parts of the earth where the ice has frozen on top of the ocean. So at the surface layer of the ocean, the ice is frozen. So there are parts of the earth like that. So life is still going on very comfortably beneath the ocean. But imagine that an alien is looking at the top of that ocean. It's gonna say that, hey, this is a dead planet. The whole surface is just white. You know, it's dead. Not knowing that there is an entire life going on down deep in the ocean. You understand? Another example is the Antarctica. Okay, so if you look at the South Pole or the North Pole, what you're going to see is a thick layer of ice. Some ice running into 50 meters deep. Ice, 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 ice. All right. It froze during the last ice age around 5,000 years ago or so. That was when Antarctica froze. So if you're looking at it from outside space, you're going to say that this is just a white region of the planet. There's no life there. But we scientists know that when you dig deep into that, you will start seeing um, when you dig deep, you start seeing bacteria. The bacteria that was alive then, before the freezing started, what they did, they formed a cyst and froze themselves along with the ice. And I was reading something yesterday night that some scientists went there, got out some of the bacteria, and defrosted them. I think they call it thawing, Thawing, thawing. They thawed some of the bacteria there that they dug out. They drilled a hole, took a sample, soil sample, and went to the lab and defrosted it. They said after defrosting it, two of the bacteria came alive. One was 36,000 years old, 36,000 years. The other one was 41,000 years old, came back to life. 41,000 came back to life. You know? So we could be looking at a planet in the distance and be like, oh, damn. Like when we're looking at Saturn or Pluto, or Uranus, we could say, oh, this is a dead planet. Come on. It's dead. The surface is just plain white. Not knowing that when you get there and actually dig deep, you could start seeing living things. Now, another thing is living things could hibernate themselves. Like that's where the living thing on Earth is going, like humans. Humans are getting to the point where we're restricting movement. Animals move a lot. In fact, there was a fox that they tracked. They put a tracker on a fox and they let it go. This fox walks about 46 miles in a day. It was just looking for food, relocating. It was just walking in the forest, 46 miles. They have tracked birds. Birds have flown across continents. A bird fly across a continent. But then the more technology the planet acquires, the less living things have to move. For instance, the ones that move too much will be killed off. For instance, cows, if they migrate too much, human beings will catch them and eat them off. Goats, sheep, lions, if they move too far, they'll be killed off. So movement is restricting. Now, what did rats have to do? Rats have to learn to live within a house. Instead of an entire forest owning the entire forest, they live within a house. And they can do their whole life there, give birth to their children, their grandchildren. As you're paying rent for your landlord, you're paying for the rats' rent too. But what does it mean? Their movement is restricting and restricting. So because the human technology is advancing, so movement is restricting. Look at what happened during COVID-19. More people stayed indoors. All right. From then on, more companies are learning to stay indoors. As phone technology improves, more people will prefer to stay and work from home rather than hit the streets. So eventually, to get to the point where we can have complete medical care online, a doctor can operate you from China, and then you are in the hospital close to you. So movement is restricting and reducing. It will get to a point where all of us live inside, you just hibernate yourself inside a test tube, put a drip in your body to be feeding you, and then you wear a what do you call it, a headgear that will put you in virtual reality. Everybody will enter virtual reality. So imagine this Earth, this planet continues in this rate of technological advancement for the next 500 years. In 500 years' time, you wouldn't even be seeing human beings moving on the streets. Everybody will be in virtual reality. Robots will be controlling everything, making sure that the systems are maintained. Grass can start growing in the streets. The streets can turn into forests. But humans will live in test tubes inside houses or cities, test tube cities. So when you have that, then our energy consumption will drop. We don't need light in the city. We don't need light in the streets. We don't need to see anything. You get? We don't need to see light in the street because we're in virtual reality. So at the end of the day, what you're gonna see is if some aliens are looking at Earth from far away, what they're going to see is nothing. Because no movement, they will be like, oh, there are no people on this planet, but actually they are humans and there are lots, and they are all in virtual reality. So those are the expectations we're having. But the primary thing is, if we can see water on a planet, then there is possibility there is life there. Now, finally, why are we even looking for life when we're outside this planet, when we have not even finished looking for life on this planet? It's a very important question, but then the answer is that life on this planet, for instance, is uh, is on the verge. It could end up any day, it could end any day. If you look at the history of this planet, you see that there has been major catastrophic apocalyptic events, about 6 of them already. Like life evolves, and then there are a lot of living things on this planet. Then something happens, boom, all of them die out, except the tiny little ones like bacteria, viruses, cockroaches, you know. Then life starts all over again, evolving, evolving, evolving. After hundreds of millions of years, another one will happen, boom, everything will just wipe out. So it's driving to that point, and the whole concept now is human beings know either instinctively, genetically, or just by studies that what we call life now could end any day. One day, you could just hear NASA announce that there's a stone, an asteroid headed for Earth, it's on a collision course with this planet. You know, it has happened before. It has happened before. An asteroid hit this planet. It was like almost 10,000 nuclear bombs hit this planet at once. And you can't tell me that it didn't even shift the orbit. It must have shifted the orbit, this Earth out of its orbit. You know, if this Earth moves even 1 meter out of orbit, a lot of things will change. The weather will change drastically and kill off everyone. So when it hit, I think it hit somewhere in Russia. When it hit the planet, there was so much black smoke that the Earth, the skies were covered for 2 years. For 2 years, there was no sunlight on Earth because of the black smoke. You know, and when there's no sunlight, plants will die. When plants die, living things will not have things to eat, then they will die too. Then the explosion alone, the amount of toxic waste that it puts in the air killed off a lot of living things. That was what killed off all the dinosaurs. The only dinosaurs surviving today, the only dinosaurs surviving today are birds, chickens, fowls, you know. Those are they are from the same avian species, avian dinosaur species. So an apocalyptic event can happen and wipe out humanity here on Earth. So that's why it's important that we humans will keep looking into the skies to see whether we have a second home. All right. It's predicted in Revelation, in the book of Revelation. John wrote, "I see a new heaven and a new earth, for the old ones have passed away." You know what I'm saying? So if we should take that prediction literally, then we should expect sometime in the future that something that will happen that might wipe out most of the life on Earth. Most. If you look at the history of Mars, you'll see that Mars has suffered something like that, and may have even got to the point where its atmosphere just disappeared. Till today, Mars does not have an atmosphere, which means life cannot exist easily there. So Earth might suffer something like that. So to prevent that from happening, we have to find another home, a second home. All right. Now the thing with human life is too short. 80 years, you are gone. Maximum 100 years, you don't go with that. So if you're calculating it based on your 80 years, it may not happen within 80 years. But if we look at in 5, 10 million years, you know, dinosaurs lived 65 million years ago. That was when the last one happened. So we could look about 60 to 100 million years coming. Something like that might happen. All right, guys, I'm going to stop here. You let me know what you think in the comment section and we can talk about it. I hope you enjoyed this episode. And if you like this, please let me know so I can do more of this kind of deep dive into the universe. All right. Thank you very much. See you guys.